Good afternoon, everybody. We'll get started here in just a few. All right, it's a few minutes after 5:30, so I'm going to go ahead and get started. Thanks to each of you for joining in today. So let me go ahead and share my screen. Okay. So you should be seeing the course homepage now. If someone will kindly unmute and let me know if you can actually see it.
Yes.
See it.
Thank you very much. All right, so just to kind of show you that I have been posting videos from each of our class meetings in the announcements, and I will continue to do so. If you want to go back and review what we did, or if you ever have to miss class for any reason, though I don't encourage that, um, you have the video available for your use and review. Okay. And so, I brought up the announcements to also mention that the announcements is something that you want to check regularly so that you stay on top of any communications that I've sent out. You can set notifications on Canvas to flag you at the device of your choice whenever an announcement is posted. So that's a good way to know when things are being announcements are being made, is to just set up notifications. All right, so let me go back into the weekly overviews. Oh, hang on a minute. Uh, let me stop the share, log out and log back in. I forgot that I logged into my RPCC ID, and that's why I can't get that screen to come up. So bear with me just for a moment. I'm gonna close that, and as soon as I get it up, I'll share again. I apologize. I'm also adjusting to teaching for multiple colleges and making sure that I log in on the right Canvas screen. So now I think I got it this time. So let me bring it up again and share my screen again. Apologies for that. Hopefully that'll be the last time, though I honestly doubt it, because I'm going a mile a minute sometimes and I just forget to switch over. So thanks for your patience on that. So here are the weekly overviews. And we took care of the nature of science material, though I do want to spend a minute just kind of reviewing some concepts and showing you some additional resources that you have regarding this topic. So I'm going to go into the announcements. And so way back at the beginning of the course, I posted this item for you. It said extra resources. Now, I'll be honest with you and say that, I am operating under this disclaimer that I don't, some of these resources might not be accessible um, if you're using a screen reader, but otherwise you shouldn't have any trouble utilizing them. It's a series of PowerPoints, and I have just not had the time to go in and convert every single item in that PowerPoint so that it's viewable with a screen reader. But there are some great notes, and that's why I just share them as some extra resources. It doesn't mean that I'm not covering the material that you need in my own notes. This is just an additional resource. But until I can make it accessible, I just offer it as something extra. Okay. So just be aware of that. All right. So um, there's some great information on, just the nature of science that you can take a look at. It has some great examples of, understanding the relationship between pure and applied, and that whole idea of the connection between science and technology, because we said on Monday that pure science is just knowledge for knowledge sake, whereas when we get into the applied area, we're talking about the various types of technology that link to that knowledge, if you will. And then kind of drills down and so that you see, what's our neck of the woods for this course. And in fact, I told you that we focus on physics in this course, introductory type physics. Problem solving is critical in this class. And in particular, we focused on Monday on the scientific method. And I even gave an example for the scientific method. You'll notice that in this example, in this packet, the steps are a little bit different, but again, it's the content overall that's important, right? And so I gave this example on Monday where the Titanic, and so I actually pulled it from here, but I put it in my notes in what I would consider an accessible format for you. And so again, some good information here to be able to refer to, okay, in terms of the nature of science and how we get things done. So feel free, and again, you can get to it right from the announcements by clicking on the folder. And what you notice is that in that folder, in that larger folder, there is a subfolder for each of the topics that we'll cover. Because at one time, these were my lecture notes. And so I just share them with students. I just have not had the time to convert them to a format that is usable for everybody. So I'll get there one day when I just have nothing to do, which never seems to happen. Okay. So also on Monday we talked about units, because I stressed the fact that in physical science we quantify properties through measurement. So we need to understand measurement, and that entails understanding measurement systems and units. And since we focus mostly on the SI system, we need to understand the SI base units and prefixes, and so on and so forth. Okay. So this, I like this because it does have the 4 base quantities. Quantity is another word for property. It's something that can be measured. Okay. And the base units and the abbreviations. Okay. And then I like this. See, this packet is even um, useful because you have a subset of the metric prefixes and powers of 10. And then this probably represents a better um, set of what we'll actually kind of use in the course, right? Rather than all 30 something, 40 something prefixes and powers of 10. This is just a smaller subset. Again, you still don't need to memorize this because you can use this anytime you like, right? I would tell students, if you want to save a digital copy of this stuff, feel free. And then when you need it, you know, utilize it whenever you're working, right? I will say that when you're doing my exams, though, you know, uh, digital access might be limited, so just be mindful of that. Okay. So in that case, you know, you might want to have a printed copy of some sort, right? Okay. So now, on Monday, I got up to introducing the metric prefixes and powers of 10. But what we didn't do was get to this idea of derived units and derived properties. Okay. And so um, maybe no, that was lab class. I talked about volume, but not in lecture class, right? So volume is one of those examples of a derived property. Why is it derived? Because to get volume, we have to make a combination of our base property. Remember, our base property, length, mass, time, and temperature. And to get volume, I have to make a combination of my base property length. So length times length. Now I know probably in a math class or in some other classes, you might say length times width times height. But if you think about it, width is a length, height is a length, right? So you're actually combining length times length times length to get what I refer to as a length volume. And for a length volume, you then have to make combination of units, right? Because every property is measured using a what? A number and a unit. So if we're going to make appropriate combinations of our length property, then we would have to take a length unit. An example of a length unit is centimeters. So to get a volume unit, all you need to do is centimeters times centimeters times centimeters. That gives you centimeters cubed. Okay. And then in this particular case, we can get another volume unit by thinking about what is the relationship between our length volume unit, centimeters cubed, and liquid volume unit. Well, in this case, 1 centimeter cubed is equal to 1 milliliter. Probably you have more experience with the concept of liquid volume, things like liters, milliliters, gallons, quarts, pints, fluid ounces. You probably utilize that more in your daily life than length volume units like decimeter cubed or any length unit cubed, inches cubed, feet cubed, yards cubed. Just take a length unit and cube it, and you have a volume unit, a length volume unit. And then you can relate that to a liquid volume unit. So in this particular case, they're relating a decimeter, which is a length unit, cubed, which makes it a volume unit. So decimeter times decimeter times decimeter gives me decimeters cubed, and that is equal to 1 liter. Okay. So when we are utilizing our base properties and making combinations of them, we call that a derived property. And we have to make appropriate combinations of our base units utilizing prefixes, which have, as we know, associated powers of 10, right? And so you see an example of that given here, taking that length volume and relating it to a liquid volume. And then we can carry it a step further. Density is an example of a derived property. And I like to say density is a derived property found by taking a base property mass with a derived property volume. So I say density is derived of a derived property, right? Because volume that is part of the density property is a derived property. So you see, you can make all sorts of combinations. Remember I talked about Monday, length, mass, time, and temperature as the four fundamental properties of our physical scratch and sniff environment that we're interested in this course. But, you know, if it was only those four things, we could finish tonight. But it's all those great combinations that we make that are going to occupy us for the next 8 weeks. Okay. So your first exposure to derived properties, volume and density. Now, density is a unique property of a substance that tells us how much mass per unit volume for that substance. Okay. And so the density formula is found by taking mass over volume. Now, let me clarify for you. When we say formula, we write out our relationship in symbol format. We're using D to represent density, M to represent mass, and V to represent volume. Okay. Now, I had a student in one of my classes before, when I asked them, tell me what each of these stands for, the student told me the M stood for mega. Well, we know that mega is a prefix, not a property, right? So this highlights a very important concept. You have to be able to distinguish context and know what context to use the symbol as, right? Because if we're using capital M as a prefix, yeah, it represents mega. But if we're using it in capital M in the density formula, it represents mass, right? So be careful when you are, you know, furthering your understanding of this material, that you use things in the proper context, okay? All right. So I want to open up a quick whiteboard if you don't mind. I'll go to my handy dandy whiteboard Fox. Okay. And I use this quite a bit so that I can share on screen some things that I might be working out at any point, like I did on Monday. And I do apologize. I owe you to post the, oh, that was lab class. I owe the lab class to post the percent error formula. I'll do that here after we're done. So you see on this page here, this nice big triangle. I call it my problem solving pyramid. And let me show you what I mean by that. I'm going to redraw it without the smiley faces, but it's something that's really useful. Oh, okay. So I use this template to help reduce the algebra. Okay. So we have a formula, density equals mass over volume. And yeah, you can treat this as an equation. If you're comfortable with equations and you want to tackle this, this formula or this relationship using your knowledge of equations, feel free. But what I like to do is take this kind of formula and put it into my problem solving pyramid. Why? Because then I don't have to worry about knowing algebra or equations. All I need to know how to do is multiply or divide. Because if I have two variables that are side by side, it means they multiply together. If I have two variables, one on top of the other, that means they divide, okay? And so, for example, let's say I'm trying to find volume. All I have to do is cover up the V, because that's what I'm trying to find, and then multiply, divide M by D, or mass divided by density. If I'm trying to find mass, I cover it up, and that tells me that I need to multiply density times volume. So I don't ever have to worry about solving an equation. I just have to worry about, do I multiply or divide to find the thing that I want? Okay. And I will utilize this consistently throughout the course as a way of making the math much simpler. You know, I talked about Monday the idea of modeling things, right? Well, I will model these equations utilizing this problem solving pyramid to make the math a much more manageable task, because all you need to know how to do is what? Multiply or divide. Okay. So I'll save this for you, because having a pyramid with three smiley faces doesn't do you much good. But I don't have a way of, um, whenever I convert the PowerPoint to a PDF, it automatically, um, I guess, writes over these guys, the variables with smiley faces. Who knew? All right. So I'll save this for you. I'll put it in the announcement with the video, you know, so that you have access to this if you want to go back and you know, you have the pyramid written out completely. All right. So that'll kind of wrap up what you know, what I wanted to cover on Monday. In this same packet, there are some examples of utilizing the density formula and utilizing the problem solving pyramid. And I have 3 examples in there, and each example finds a different variable in the formula. So if you are practicing, as you will have to do on problem set number 1, finding a particular variable in the density formula, then you can look at these examples, and they can, that can help you. Also, in the weekly overview itself, if you click on if you go under activities, let me just do it instead of talking about it. You can see it right here. So in the this is where you get the problem set number 1. You see here, use the sample density problems under useful links. So that not only do you have some help here, but you also have some help within the weekly overview that you can go to, where they solve some sample density problems. We can take a look at, I'll take a look at one from here and from there, just to kind of show you what's there so that you can utilize it as you need to. Okay. So I'm gonna solve the second one here. Let's see. Find density. Yeah, this one here. The numbering is a little bit off. Yeah, but that's okay. I think we still get the idea. So a liquid has a density of 0.87 grams per milliliter. You see these density units, right? Okay. The way you get a density unit, you take a mass unit and divide by a volume unit. Well, if in the formula you take mass divided by volume to get density, then you know you have to make well, put it, the unit has to be consistent that way as well. You have to have a mass unit on top of a volume unit to get a density unit. Okay. So it says here, what volume is occupied by 25 grams of the liquid? Well, they're asking you for volume. So you cover up volume in the pyramid, and that tells you what? You take mass divided by density. 25 grams divided by 0.87 grams per milliliter, because they gave you the density, which goes on in the denominator in this case, and they gave you the mass, 25 grams, which goes in the numerator in this case. Well, this is written out real nicely using the equation, but if I'm looking at my pyramid, I could just put those values here and here, the mass here, the density here, and I know I have to divide, right? So now when you divide, the grams cancel out because you have grams in the numerator and denominator, and you're left with milliliters, which is an appropriate volume unit, okay? So because you're dealing with this derived property density, you have to make sure that you deal with the units correctly, right? Density, a mass unit divided by a volume unit. And that could be any mass unit divided by any volume unit. So let's say I had the mass unit kilograms. and I had the volume units gallons, kilograms per gallon. That could be a density unit. Kilograms divided by gallons is an example of a density unit. Why? Because I took a mass unit, kilograms, and divided by a volume unit, gallons. If I had the mass unit, ounces, and I had the volume unit, fluid ounces, I could take ounces over fluid ounces, and that would be a density unit. Ounces per fluid ounce. Why? Because I have a mass unit in the top divided by a volume unit and on the bottom, or the denominator, right? Okay. So making those appropriate combinations of units to get this derived property density is something that you will get to you'll get to practice. Okay. All right. And then I wanted to take a look at one of the sample problems under useful links. So under useful links, you see it clicks and it takes you there. And look, you'll see here, sample density problems. Okay. And I did that on purpose because I wanted, right from the weekly overviews, I wanted you to click back to this and see all of the great tools and resources you have beyond the items that I put in each weekly overview. Okay. So some density problems being solved here. Okay. So you can see. Um, let me look at one of them here. It says, you decide, I'll do problem number 5. Problems 1, 2, 3, and 4 are fairly straightforward. The thing I like about it is that you do have the solutions available. So, you can try it on your own and then you can check yourself, right? It says you decide you want to carry a boulder home from the beach. It is 30 centimeters on each side. So this is a cubic boulder. However that happened, I don't know. But it's a cubic boulder, right? And so it says, and so has a volume of 27,000 centimeters cubed. How did they get that? They took 30 centimeters times 30 centimeters times 30 centimeters. Okay. And so they got 27,000 centimeters cubed, right? Because we took our length unit, our length measurement, and we multiplied it, right? Length times length times length. It says it is made of granite, which has a density, typical density of 2.8 grams per centimeter cube. How much will this boulder weigh? Uh, well, I would have asked the question, what will be the mass of this boulder? Because weigh is actually a different property, but we'll live with that. Okay. So if we want to get the mass, go back and take a look at our problem solving pyramid. If we want to get the mass of our boulder, then we have to take the density times the volume. Okay. So we have to take the density, 2.8 grams per centimeter cube, times 27,000 centimeters cube. And so here we go. Okay. To get the mass, we multiply density times volume. So substituting in, volume was 27,000 centimeters cubed times 2.8 grams per centimeter cube. That gives us a mass of 75,600 grams. Okay. And so what happens when we multiply here, the centimeters will cancel, centimeters cubed will cancel out. And we're left with the unit grams, which is an appropriate unit for mass. Mass has units like grams and kilograms, and put any prefix, and megagrams, nanograms, or things like ounces in our English units. Sometimes you hear it referred to British units or imperial units. Ounces would be an appropriate mass unit if you are working in that other system. Then in the British system, sometimes you'll see, well, a real old British unit is slugs. We rarely use those, right? We still typically stick to grams and kilograms and micrograms, megagrams, things like, SI units with utilizing our prefixes and powers of 10. Okay. So you have access to some great tools to help you understand this concept of derived properties and derived units. And you'll practice that in your problem set number 1 and the discussion on measurement. Okay. So what I want to do now is move into our unit conversions. That's our goal here, is to talk about unit conversions. And then I'll try to leave about 10 minutes toward the end of class, and I'll introduce the project to you. I haven't forgotten that I need to do that as well. Okay. So let's take a look at this whole idea of measurement. And so regarding this measurement 2, that deals with unit conversions, you'll be answering questions in this discussion, and you have to answer these questions and then reply to 2 of your classmates. And then problem set number 1. Now, problem set number 1 deals with the nature of science and the SI, and introduction to the SI system, right? And then derived properties. Okay. So the way I like to do, I mean, it kind of, because of the condensed schedule, typically what I have you do is a discussion on a topic before you do a problem set. But the way things are falling in this semester because of the time frame, you're going to be dealing with all of the nature of science and measurement all in one. So all of that work is due this Saturday. Okay. So what I would say to you is, while you're working, if you have questions, don't hesitate to reach out to me, because I know we're moving at a faster pace than a typical 16-week semester. And I know that means that, when you're working, there are going to be some things you have questions on. Don't hesitate to reach out to me. Okay. So in the required readings viewings related to the measurement 2 overview, you have chapter 1 in the textbook. Remember, I told you I would take each chapter that we utilize from the textbook and put it in the appropriate overview so you have access to it right where you need it. Okay. So this chapter in the CK12 textbook deals with this idea of measurement and unit conversions. So you should read the textbook. And then if you have questions, you can ask. That's why I always tell students, look at the textbook materials ahead of time. If even if it's just to skim through it, that way, if something catches your eye that doesn't make sense to you, you can ask your question when we meet. Okay. There's some videos that deal with measurement as well, related to unit conversions. You can take a look at the video. The textbook and the videos are your responsibility to deal with and ask me questions. The supplemental notes, that's where I cover and work examples for you. Okay. So I'm going to do that now. Go ahead into, well, actually, I did pull some of this from the textbook. So I mentioned this idea on Monday that one of the important aspects of science is communication, right? And I mentioned the fact to you that we utilize certain terminology, certain techniques and methods to facilitate that communication. I gave the example of the SI prefix chart um, as an example of that, right? As an example of how we utilize um, certain terminology, certain tools to simplify communication. And so we add to that communication piece the idea of unit conversions. So we might have a colleague that's working out in Europe and using the metric system, and you're in the United States using our typical English or British system, and you want to communicate about the work that you're doing. Well, because you're measuring things using different unit systems, you have to have a common way of understanding each other. And so to facilitate that understanding, we have, we convert from one unit system to another, right? And that is to facilitate communication so that we're comparing our measurements on an equal basis, okay? And so uh, if we're going to adequately understand this concept of measurement, then we need to also understand this idea of unit conversions, okay? And so I like to use a technique that I call dimensional analysis. Dimensional analysis. Now, to do dimensional analysis, you need what is called a conversion factor. A conversion factor. A conversion factor is nothing more than a fancy way of writing one. Well, that's a beautiful thing because the number one, when multiplied or divided, doesn't change the value, right? We learned that very early. Multiplying by one or dividing by one doesn't change anything. So because I am multiplying by one, I don't change the value. In fact, all I do is I find an equivalent in a different unit, okay? And so where do you get these conversion factors from, okay? So many times in textbooks, there are conversion charts in the front cover or back cover. They may have an appendix where they have conversion charts. Sometimes you can utilize online unit converters. And in fact, if you go into useful links, one of the very first items is a unit conversion tool, okay? And I always tell students, you can use this conversion tool to your liking. I don't want you memorizing conversion factors. There's no need to do that. You just simply need to use the conversion chart that's available to you, okay? And no worries, if you have to do a conversion like on an exam, where it's a pretty closed system and you don't really have access to like a whole bunch of outside material, then I'll make available to you a conversion chart with the things that you need, okay? The conversion factors that you need. And you have an example here of a conversion chart. This conversion chart is comparing quantities in the English system. There are no, they do have some here. They do have some metric conversions, but they're comparing metric measurements to metric measurements, right? They're not in this chart. What they do, the very last one is a conversion factor that'll take you from centimeters to inches. Okay. So the nice thing about the dimensional analysis technique is that as long as you have a conversion factor, you can you can convert, you know, from the unit that you have to the unit that you want. Okay, so I like that technique. Okay, so let's I while I do appreciate the examples that they have here in this these examples here from the textbook, uh, I like to do ones where we actually go from the metric system to the English system or vice versa, or convert within the metric system. Okay. So I'm going to go and rely on my handy dandy extra resources again, because guess what? I have quite a few examples worked out in there that you can rely on. And then there are some other great examples done in the videos that you have access to. Okay, so we'll skip over that part and go right to the dimensional analysis technique. So we're relying, when we do a conversion using the dimensional analysis method, we are relying on the fact that we can cancel out units just like we cancel out like variables. Okay, like units cancel just like variables. Or you can think of it this way. Um, you know, sometimes when you're multiplying fractions, you can cancel out multiples if you have them, right? If the numerator and denominator are both multiples of the same number, you can cancel out portions of it. Same idea here, right? If I had 1/5 times 20 over 4, I could do some canceling there because, you know, I have um, some factors in common. All right. So this talks about the process that you go through when you perform dimensional analysis. When you perform a dimensional analysis, um, you have to be very clear about, well, what unit do I have and what unit do I want to end up with? What unit am I starting with and what unit do I want to end up with? Okay. And then you have to arrange your conversion factor so that you cancel properly. All right. And we'll look at that when we work some examples here in just a moment. And then you multiply all your top numbers and divide by the bottom numbers. Okay. I'll emphasize that as well. And then of course, always check yourself. You know, that's an old math rule when you're working math problems, check yourself, right? So the question becomes then, how do you know how to line up a conversion factor, right? Because, you know, I could give you all the conversion factors. I could give you access to all types of conversion charts. But if you don't know how to properly align the conversion factor so that you cancel properly, that's sometimes where students have trouble. Okay. So remember, I said that a conversion factor is nothing more than a fancy way of writing one. Well, if you look on a conversion chart, the textbook rounded to 2.2, but this one writes it out to 2 decimal places, and I like that actually better. 1 inch equals 2.54 centimeters. Okay, 1 inch equals 2.54 centimeters. These things are equivalent. You'll find that in a conversion chart. And so if I divide 1 inch by 2.54 centimeters, because they're equivalent, I get 1. Well, notice how this is aligned. The inches are on the top and the centimeters are on the bottom. When this conversion factor is aligned or lined up with the inches on top and the centimeters on the bottom, it means you're trying to convert from centimeters to inches. Okay? From centimeters to inches. Now, honestly, I could get all exotic with this, but I try to keep this simple because I know this is an introductory process for many students. And so in this class, when we line up our conversion factor, we line it up in a way so that we cancel out the unit that's on the bottom of the conversion factor and keep the unit that's on the top. Because if it's aligned like this, it means we're starting out with centimeters and we want to convert to and keep our inches. Okay. So I keep it simple in here. The unit that's on the bottom of your conversion factor is the one you want to cancel out. And the one that's on the top, or the numerator of the conversion factor, is the one you want to keep. Now notice, on this bottom conversion factor, notice that again, that we're dividing two things that are equivalent, so we do get one. But notice that it's aligned or lined up differently. It's lined up so that the centimeters are on the top in the numerator and the inches are on the bottom in the denominator. In this case, it means that we want to cancel our inches and keep our centimeters. Okay, so you have to take that conversion factor. 1 inch equals to 2.54 centimeters and line it up appropriately. Okay, so let's take a look at a couple of examples, and I'll try to save a few minutes here, wrap up in a few so that we can have time to talk about the project. Okay, so it says here, your European hairdresser wants to cut your hair 8 centimeters shorter. Now, I don't know about you, but I don't have a European hairdresser, and I don't normally think in centimeters. I think in inches. So I would have to take this measurement of 8 centimeters and convert it to inches. So I'm starting with 8 centimeters. Notice the quantity that I have, I put it out front by itself, nothing in the denominator. Somebody's mic is open. Please mute your mic. Okay. So the 8 centimeters is out front because that's the measurement that I have. And then I take my conversion factor and I line it up so that the centimeters are on the bottom of my, of my fraction. Why? Because I want to be able to cancel centimeters. Now I have to multiply on my top numbers, 8 times 1, and then divide by 2.54. Now notice the inches didn't cancel because that's the unit I want to end up with. So that becomes 3.15 inches. So if they're going to cut 8 centimeters of my hair, they'll be cutting an equivalent of 3.15 inches. Okay. So that's just a simple example of how you line up the conversion factor. Okay. And here for our purposes, so that we can just get our, get a basic understanding of converting, we always line up our conversion factor so that we cancel out the unit that we have, which is always going to be on the bottom of our fraction. Okay. All right. Let's take a look at another example. It says, how many milliliters are in 1 quart of milk? I like this example because I am taking milliliters, which is, a whole lot smaller than a quart. And I'm trying to figure out how many milliliters can I put in a quart. All right. So I'm starting with a measurement of 1 quart. Okay. So I write that out front. And then I have to go and get conversion factors that will help me to move from quarts to milliliters. Now, I could look up one of these internet conversion charts like the one I provided you and find a conversion factor that'll take me directly from quarts to milliliters. I could do that. But if I'm using a conversion chart that you typically find in the front cover of a book or, like in an appendix, you don't find all of the conversion factors you find the most logical conversion factors, meaning what? You find conversion factors that relate two quantities that are close in size. I say logical, a logical conversion. It's logical to go from quarts to liters because a quart and a liter are pretty close in size. And so you would typically find that conversion factor available. 1 liter is equal to 1.057 quarts. 1 liter is equal to 1.057 quarts. But when I line up that conversion factor as a fraction, I need to put that 1.057 quarts on the bottom because that is what I will be canceling. I need to get rid of my quarts. So that's why it's on the bottom of the conversion factor. The conversion factor is 1 liter per 1.057 quarts. Now, once I do that first step, I no longer have quarts. Now I have liters. And so I have to convert my liters to milliliters because they didn't ask me how many liters were in a quart. They asked me how many milliliters. So a conversion factor that you will find in most conversion charts is that 1,000 milliliters per 1 liter. Okay, these are both metric measure SI measurements, right? And so 1,000 milliliters per every 1 liter. That's a conversion factor. And I have to line up that conversion factor so that I get rid of these liters because they didn't ask me for liters, they asked me for milliliters. And then I take all my top numbers, 1 times 1 times 1,000, and divide by 1.057. And that'll give me 946 milliliters. Okay. So that's an example of how you could do this. If you want to do everything all in one process. But sometimes students like to take things step by step, and that's perfectly fine. You could have converted to liters first, got a value, and then converted those liters to milliliters. Okay. So if you took 1 divided by 1.057, you'll get 0.946 liters. And then you multiply that times 1,000 milliliters per every 1 liter. And you'll come up with 946 milliliters. So you can do it all in one, aligned like they're showing here, or you can break it down in parts. Either way is acceptable. I tell students, hey, as long as you're showing me your work and you're setting things up appropriately, I don't have a problem whether you do it all in one or break it down into parts. What's important to me is that you're following the right process and you're getting the correct solution. So show me your work, and then, if you got the correct answer, great. If you show me your work and you didn't get the correct answer, I can tell you where you went wrong and help you to figure out how to correct that. But if you just write out an answer, I'm not going to give you credit for it. You have to show me your work. Okay. All right. So let's take a look at another example. This one's pretty straightforward. So I'll move to one that's a little bit more involved. And that'll be the last example I work. And then you have access to this. You can come and look at the other examples that are worked. Okay. How many feet long is a 5K, 5-kilometer race? Okay. So I have 5 kilometers. Ultimately, I want to know how many feet it is, right? So the first thing I'm going to do is I got to find a way to get rid of these kilometers. And so I look on my conversion chart, and there's a conversion factor. 1 mile equals 1.609 kilometers. 1 mile equals 1.609 kilometers. So now what I got to do is take that conversion factor and write it as a fraction. And I write it as a fraction so that the kilometers part is in the denominator, because that's what I want to cancel out. Okay. So Now, once I've canceled out my kilometers, I have miles, but they didn't ask me for miles. They asked me for feet. So now I need a conversion factor that'll help me convert my miles into feet. And if you look on the conversion chart, you'll find that there are 5,280 feet in 1 mile. So I take that conversion factor and I write it as a fraction. And when I write it as a fraction, I have to put in the denominator the unit that I want to cancel out. In this case, the miles. So my miles cancel out. And now I have to take my 5 times 1 times 5,280 and divide that by 1.609. And notice my kilometers are gone, my miles are gone. The only unit I'm left with is the one that I wanted, feet, 16,408 feet. Okay. All right. So now, those are a couple of examples of how you utilize the dimensional analysis technique to do a conversion. When you do a dimensional analysis conversion, you need to utilize a conversion factor, which is a fancy way of writing 1. But the great thing about that conversion factor is it'll allow me to go from one unit to another. Whether I'm going from metric to English, or English to metric, or metric to metric, English to English, it doesn't matter, because with a conversion factor, I can do any conversion that I need to, as long as I line up my unit of my conversion factor appropriately, right? So there are several more examples that I didn't work out in here. Feel free to take a look at them. Again, these are the extra notes. You can find that in the extra notes, right in the announcements. And while you're working and practicing that, if you have questions, don't hesitate to reach out to me. This measurement piece is critical, because the work that you'll do in the upcoming overviews is based on measurement, right? Physical science is based on measurement. So you got to understand units, and you got to understand how to convert units, okay? Before I jump into the project, any quick questions that you want to ask me?
I have a question.
Yes, please.
On the PS number 1, I'm a little confused. Are we, like, what numbers are we using for the SI units? Like, are we, like, we just
What
have to fit
numbers?
like the milliliter?
No,
Can you hear me?
yeah, it says for each of the following commonly used measurements, indicated symbol. So it's asking you for
Okay.
deviation.
Alrighty.
Yeah. And then here it's asking you to make a guesstimate. You know, like make a guesstimate. Do you think a bowling ball is 7.25 grams, megagrams, kilograms? Make a guess utilizing units.
Okay, so you just want us to guess on that part.
Yeah, I mean that's the whole idea here. I mean, you don't have any way of measuring this thing, right? I mean, I'm not asking you to measure a bowling ball. I'm asking you to write in what you think would be the most appropriate unit here, right? A metric unit.
Okay. Alrighty. I think I have my understanding then. Okay.
Yeah, so like the mass of a paper clip is about 1. You know, do you think it would be centigrams, megagrams, micrograms? What unit do you think will work most appropriately here? Okay,
Okay.
that's what they're asking you.
Okay.
Any other questions? Please don't hesitate to ask. All right, so I'm going to go in under the assignments and activities menu, and I'm going to choose project. There are other ways you can get to the project, but that's the way I like to go. I utilize the left menu, and then when you click on that, you'll see a link that says project. Okay. So I'm going to go into project details because what I want to do for you is to get you started on the project now, because I just mentioned we're moving a mile a minute, and so you don't have much time to do this. Okay. This project this semester. So you got to find an article and get busy with it. Okay. So the goal for this project is for you to summarize a peer-reviewed research journal. Okay. So you're gonna find one of these peer-reviewed articles. You're gonna read it. You're gonna tell me what it's about in your own words, and you're gonna have to tell me how it relates to the class, right? Whether that's lecture or lab. If you're in lecture and lab, you have to do two different projects. That's why it's important that you get started now. Okay. This project is not an easy thing to do. It's time consuming. And so you got to get started now. So let me break down for you what a peer-reviewed research journal article is, and then we can talk about, specifics of what you're going to be looking for. All right. So there are scientists that are out there actively doing research. Some of those scientists are pure scientists, and they want to find new knowledge, right? Add to our body of knowledge. And then there are some scientists out there that are applied, and they're more on the technology vein, right? They try to take our knowledge and find better technology for us, right? And so better ways to use the knowledge. And so when they're finished their research, what they do is, in order to communicate with the scientific community and folk at academic institutions and the public, they write research reports. And those research reports get published in research journals. Okay. And so your task is to find one of those research reports that's housed in a research journal. You find that article, you read it, you summarize what it's about in your own words, and then you tell me how it relates to some things you're learning in this class, or for those of you in lab class, or for those of you in lecture and lab, both, right? And again, if you're in lecture and lab, you have to find two different articles and you have to write two different summaries. Okay? Be clear on that. Now, these articles have to
Excuse me.
yes.
I have a question. You said find the articles. How long does the
I,
article? I mean,
I'm getting there. All that's
okay,
outline, but I'm getting there. Okay.
okay.
All
Hmm.
right. So the article has to be related to astronomy, mechanics, which is motion. Mechanics is another word for motion. Remember, I said on Monday, we're doing Newtonian mechanics, which is study of motion that can be explained utilizing Newton's laws. So astronomy, motion, energy, waves, or thermodynamics. Those are the topic areas, the broad topic areas that your article has to be about. Okay. And it has to be from a science perspective. I don't want economics articles. I don't want philosophy articles or history articles. I want articles that approach these topic areas from a physics perspective, not chemistry, not medicine, unless there's a solid connection to physical science. You can't use the article. Okay. And we'll talk about how you get it approved here shortly. All right. So one of those five categories. All right. Now, how do you find these articles? Well, you have access to um, your school's library, and in fact, under I have a link to it. Maybe in the syllabus there's a link to your library, but you know how to get to Nunez's library. It's available from their homepage, right? So, right, yeah. In fact, under course documents, there's student resources and there's access to the library there, right? So you could utilize library resources, right? The college has access to what are called electronic databases. They pay a subscription fee so that students can access electronic databases. You can think of these electronic databases as like a warehouse which stores lots of electronic journals. And in these electronic journals are research articles. So if you use your college's electronic databases, you can find an article through that process. Now, here's the thing. I don't tell you how to use your school's electronic databases. You work with the librarian to help you understand how to use those electronic databases, because that's part of this project. Not for me to teach you how to use them, for you to learn how to use them. Okay. All right. You can also find these scholarly journals online, but please be careful. If you try to Google and utilize electronic journals online to get an article, most times they'll charge you for it. And I don't want you paying for these articles because they can cost about $30, $40 a piece. So please do not try to Google and find an article, because a lot of times, if that happens, you'll spend money. And then if it's the wrong thing, you lost your money. The school's electronic databases are a free method of finding the article. Okay. Another method of finding an article is through this website, hindawi.com. You can just simply click the link here in the project details, and it'll take you to the website, Hindawi. Hindawi is what we call an open education resource, an open education database, okay? And they house open education journals, meaning you can utilize them at no cost, right? So you can just go to that website and search and find an article. So I'll open up the website just so we can take a look at it. Okay. And so it makes, scientific materials are freely available to you. The way you find it is you hit the search button and you type in what it is you're looking for. What typically has to happen is that you'll do a broad search on one of these 5 categories, and then you have to start to drill down and find something that you're interested in. Okay. So if you search for, you just put in astronomy there, you're going to get a million articles. You have to start thinking, well, what about astronomy am I interested in? Let me just find those articles. And then you narrow your search that way. But that's a process that you're learning through this project as well, how to find things utilizing these resources, right? For those of you that like to use apps, you can install this RXiv app, right? And you can find it by going to the Google Play Store or the iTunes Store. If you do a search for this ARXIV in the either of these, you'll see this logo. That's how you know you found the right app, because the logo will look just like the one that you see here. Okay. So now you know what you're looking for. I've given you 3 methods of finding: your school's library electronic databases, this Hindawi website, or this RXiv app. Okay. Beyond that, if you use some other method, I don't have a problem with that. Just be careful, because I really don't want you paying for these articles. Okay. All right. Now, so you know what to look for. You have methods of finding it. The other requirement is that the article that you're looking for, not your summary, the article itself must be at least 15 pages long, not counting the references. Let me show you what I mean. Just by taking a look at an article, this by no means means that this is an article that you can use, but please, I'm just doing this to highlight what an article might look like. So let me just, I'm gonna click in there and let's see if I, let me do a quick search. I'll do astronomy. Okay. And I did a search there, and look, there's an article that came up. All right, so I'm gonna look at that. All right. So you see, I found an article. Now the question is it long enough? So uh, the nice thing about Hindawi is that you can simply download the article as a PDF. And look, this article is only 2 pages long, right? And so what you're looking for here is, if the article is long enough, meaning it has to be at least 15 pages long, not counting the references. So when you open these articles, they'll have lots and lots of references at the end. That cannot be part of your page count. So in other words, references must start on page 16 in order for the article to be long enough. If the references of the article start before page 16, it's not long enough. Okay. So now you know what topic areas, you know that the article has to be at least 15 pages long, not including the references. All right. Now, how do you know if your article is acceptable? You have to send it to me by email. So just like I just downloaded that PDF, you download the PDF and you attach it to an email, send it to me and say, hey, Doc Z, can I use this article for my project? And I will take a look at it and tell you, yeah, you can use this article, or no, you can't use this article, and here's why not. So you send me the full article as a PDF. I will review it and tell you if you can use it. Okay, and all that's outlined here for you. And you have until Saturday, June 26th at 11:59 p.m. to get your article approved. If you don't get it approved by that deadline, you automatically lose 20 points off the project. You must be working with an article that's approved, or you automatically lose 20 points. And we'll talk later about some additional possible consequences after this deadline. But that's why I'm getting you started early, especially if you're in both classes. You have to do this twice because you got to find 2 different articles. And we'll talk about the actual writing later. Right now, what I want you to focus on is finding an article and getting it approved. Okay? All right.
I have a question.
Yes, please.
So after we get everything approved, like through you, you would tell us what exactly you want in the articles, correct?
Well, if you're getting the article approved, that means it has what I'm looking for. You mean
No,
what I'm telling you how to write what goes in the summary.
So I'm guessing the summary would be, okay, so I'm just trying to make sure I'm understanding everything correctly. So I send you 2 different articles because I'm in lecture and lab. I send you 2 different articles. They get approved by you, and then I can start on them.
Yeah, then you start reading them. You start reading them. And then we'll talk about what format your summary has to be in and all of that, right?
Okay, so it's not my summary.
You are writing the summary. You have to write a summary of the article.
Yes, I know. I was trying to finish. So I'm writing a summary of the article. Just the article itself has to be 15 pages, not my article or not my summary, correct?
That's right. That's why it says right here, okay, your article, not your summary, must be a minimum of 15 pages long, not counting the references. It tells you that right in the project details. Does that answer your question?
Yes.
Okay, great. Any additional questions, please don't hesitate.
So my question is it's the same question as Amanda's. I just want to clarify things properly in my understanding.
Mm-hmm.
15 pages is the article, and then the 2 pages is our summary that we write.
Correct.
All right, thank you.
Yes, ma'am. Anybody else, please ask.
In our summary, I'm just trying to get ahead a little bit just because I know I'm in both lecture and lab.
Yes.
The summary, you just basically want us to summarize the 15-page article that we are doing, correct?
That's correct.
Okay.
And we'll talk more about the actual summary that you have to write, that you have to type. I'll say write, but that's what I mean, type it, right? We'll talk more about the formatting and all of that kind of stuff here in a couple of class periods, because I want you to have time right now and find the article, right, and get it approved. And then I can guide you through, you know, the particulars of the actual summary, but you need to have an article approved and you need to be reading that article, and then we can talk about what it is you actually have to write. Make sense?
Yes.
Good, good. Okay, so look, why you ought to go ahead and get started trying to find these articles, especially if, you know, as one student mentioned, they're in lecture and lab. You are going to find that it's number one, it's a process of finding an article that's approved, and number two, these articles are not easy to read at all. So you're gonna have, give yourself time to be able to read and digest the article so that you can tell me in your own words what it's about and tell me how it connects to the things you're learning you're learning in class, right? So go ahead and get started. If you have questions while you're looking for an article, please don't hesitate to reach out to me. And definitely, if you found something that you think meets the standards and you want to work with, email it to me so that I can take a look. Okay. And then we'll just keep at that process until the deadline. And then I'll start, bringing you on board with the writing that you have to do. Okay. All right. So I'm going to stop my sharing now. If you have questions, I do have a few minutes to hang around before the lab class actually starts. If you're good and you're ready to go out and get the assignments that are due by Saturday done, and you're ready to, start the process of finding an article, we're done for the day. I appreciate your attention and joining in this afternoon. And I'll see you back here Monday at 5:30.
Thank you.
You're welcome.
Are you going over anything differently in lab, or is it basically the same stuff?
Well, the explanation of the project is, is pretty much the same, right? The difference is that there was one more experiment, the density experiment, that I needed to explain to you. And so I'm going to be doing that in lab. Now, I've had several students already reach out to me who've done the density experiment. So, if you're good, I don't know. I mean, if you feel like you want to hear the project explanation again, feel free to join in, and if you want to hear my coverage of the density experiment, we'll get together here at what is it, 7:00? Yeah.
I've done the density assignment already. The only thing I had something to ask you about was for the mass data, what is on the volume, what was the PI? What does the PI stand for in the volume part? That was the only thing I was confused.
How about, let me wrap this up here, stop this recording, and then I'm gonna go into the lab class link and you can join me there just for a few and I'll answer that question. Is that all right?
Okay, that's
all right.
yes.
All right, cool.
Thank you.
Yeah, no problem. All right. If there are no further questions, we're done. I'll see you back here on Monday.
Thank you.
You're quite welcome. Y'all have a great weekend.